Welcome back to First Line. You might think you have a good sense of direction, but have you ever wondered how you know where you are? Well, this year's recipients of the Nobel Prize in Physiology or Medicine might just have the answer.
In work that spans 3 decades, John O'Keefe, May-Britt Moser and Edvard Moser have found that our brains have an inner GPS. To explain a bit more about this, we're joined now by Steve Pointing of AUT. Good morning, Steve.
Good morning.
Tell me a little bit about this fascinating discovery.
Yeah, well, so this was the Physiology of Medicine Prize just announced yesterday, Kiwi time, so it's hot off the press. Essentially, this prize was awarded for 2 discoveries. So John O'Keefe made his discovery in 1971, and what he did was, using rats as a model system, he was able to identify cells within the brain called place cells, and these cells were activated when the rats were in a certain location. And in every separate location the rats were located in, different sets of cells were activated, essentially forming a cellular map in the brain of where they were. And then later on, the Mosers in 2004, who actually did work with O'Keefe in their early careers, made a separate discovery of another type of cell in the brain called grid cells. And these grid cells acted to essentially create a pathfinding instruction for the brain. So combined, the place cells and grid cells do provide, as you say, like an internal GPS for the human brain.
And in terms of use of that knowledge, I gather understanding of Alzheimer's could be improved.
It could well be in time, yes. I mean, it's an amazing discovery in its own right. But of course, what's very interesting is that with degenerative diseases such as Alzheimer's, the first part of the brain that shows symptoms of degeneration is usually the hippocampus, and that's actually the area where these place and grid cells are located. So I think there's huge potential there. Once we understand how the cells are defective, then we can start to understand how to repair or mitigate the damage.
Of course, now Ebola's been a big topic in the news, a worrying topic at that. There's been a study, though, that's shown how social structure and transport networks influence the spread of the disease.
Yeah, this is a very interesting study. It was actually carried out on HIV because, of course, HIV has been with us for a long time. This study was groundbreaking in many ways. It used molecular genetics to understand the history of the disease. So what it basically did was look at the genetic signature of HIV in spatial and temporal scales. And the main discovery was that we now know that HIV in its pandemic form, which is the M form of HIV, originated in Kinshasa, which is what is now in the Democratic Republic of Congo, and then spread out into sub-Saharan Africa. But that spread, and this is the key point, that spread was very closely correlated with transport networks. And so we do have a huge worry there. And what's even more concerning is that even back in the 60s, when there was a huge amount of migrant worker flow between the Caribbean in Haiti and Congo, that was also a factor to explain spread of the disease. So, of course, as you can imagine with Ebola, and we have a much more developed transport network around the world now, we really need to pay more attention to responsible management of Ebola, lest it become pandemic.
Sure. Now, on to latest studies of cancer. Now, there's a new study that's come out that suggests cancer growth is greater at night time compared to daytime?
That's right. This is a fascinating study, and it's a really good example of how a fortuitous discovery essentially was made from a group, in this case the Weizmann Institute in Israel. They were actually researching something else. They were looking at cell signaling and understanding how cells process signals externally. But what they found was this. During the day, we secrete a hormone called glucocorticoid, which is essentially the hormone that determines our wakefulness or activity. It's sometimes also called the stress hormone because it's secreted in large amounts when we're stressed, which is why we feel very hyper when we're stressed. However, at night, this hormone is suppressed. And what the researchers found was that hormone is preferentially recognized by cells, but at night, when its levels are depressed, another factor called epidermal growth factor takes center stage. And that has obvious benefits to the human body in that it modulates repair and migration of cells in the body, but unfortunately it also benefits cancer cells. And so what this study shows is that at night time the body is less able to defend against cancer, and so it may be that we should perhaps think about adopting changes to therapeutic regimes so that we can take advantage of that and make treatments more effective.
Quite a significant discovery there. Okay, thank you very much for coming in.
My welcome.